Hey, good morning. So this is a quick solution video for the coin flip that some of you struggled with a little bit last week. So I want to start in kind of thinking of if I got asked that I needed to create a coin flip of 1,000 times, what kind of steps and what kind of things would I do? So I would first look at my pseudocode and I would write down what kind of steps am I going to do. I know that I need to make it repeat, so I know that there's going to be a loop. The other task in here, so there was really a couple of pieces. One, you had to be able to create a coin flip of 1,000 times, record the results, and display them. The other part was you had to then allow this program to repeat. And I went and I tried to show most of you, or a few of you, or however many decided to watch the video, which you'll see in an email. Not a lot of you did, which I think is going to be an issue. I know that time is always hard to come by, but you need to work through the material. You need to spend some time on the video, looking at what I've done and what I've tried to show you. Quite frankly, last week for the Tuesday video, or essentially the Tuesday video part 1, I only had 12 viewers, 12 people, and I think one of those was probably me going back and looking at it. Well, there's 30 students in the class. That's not a really good percentage. So I'm trying to make these so they are useful and helpful, but I have to get you guys to reach out and do it. And I know the situation's a little weird, and our time is always very valuable. But let's take a look and see what I would do in this program. Anyway, all right. So I know I'm going to call this coin flip challenge or whatever I'm going to do, and I'm going to have my name. And I still had several people that did not put their name on these assignments. Make sure you do that. So I know that I'm going to use some random things, and so I'm going to have an import random. Now, one thing I saw several people went out and did was, hey, I'm going to go find some resources on some sites outside of these. That part is great. However, if you download code or grab code and you don't know what it does, that doesn't really help you. And so one of the things I saw was several people went to a website that had a challenge similar to this. It was to flip a coin 100 or 1,000 times, but it used some tools that we haven't gotten to, or probably won't actually in this class. So if all of a sudden I'm downloading things like the iterative tools, or yes, if you can figure out how it works, that's great. If you can't, there are always different ways we can do this. And I'm not going to make you go out and find tools that we haven't explained or looked at. You might find some solutions that are more interesting, but you need to be able to understand how these things function at this very kind of basic level. So the first thing I'm going to do is I know I'm going to have a while loop. So I'm going to come down here and I'm going to create a while loop. And I know that I'm going to have a counter, and I'm just going to call it counter, and I'm going to say it's equal to 0 to start my program. That counter, I want to go all the way up to 1,000. I could program it in like this. I could say while counter is less than 1,000, but that presents a hard coding in my program here, and I don't really like that. So what if I said my target is equal to 1,000? That way, if I needed to, I could change this really easy. And so now I'm saying while counter is less than target, we're going to create some kind of a loop. That loop is controlled by this idea of everything being inside this block. And so I noticed a lot of people still had some indenting issues. You would get pieces of the loop in there, and then you would go back all the way to the left, and it wasn't included in the loop. So those things that are inside this loop are going to be those things that are going to run. In this case, it's going to run 1,000 times, 0 through 999. So I'm going to look at creating a variable. And I'm going to call that variable coin. So I'm going to put it up here, and I'm going to set it equal to 0, just so I already explicitly know there's no garbage in there. And so I'm going to say coin is going to be equal to random.randint. The other piece I saw in here, just so I'm kind of commenting as I create these, is the random range and random integer. Random integer, really quickly, I can just put in a range A to B, and so in here I'm going to say 1 to 2. If I did rand range, I could do very similar structure, but rand range takes something a little different. And I like, in this case, rand integer. So it explicitly says I'm going to have a value between 1 and 2. And that includes the 1 and the 2. Now I need to figure out how do I get a couple of values for how many tails I'm collecting and how many heads I'm collecting. So I'm going to create a variable called tails, and I'm going to set it equal to 0, and I'm going to have one called heads. I'm going to equal that to 0, because I want to keep track of heads and I want to keep track of tails. Notice we're indented at that first indent level. And I'm going to use an if statement. So if coin is equal to, and notice when to do the equals, I had to do 2 equals. You'll see me screw that up quite a bit. So if you do the same thing, don't worry about it. It'll return a nice little error message, and then you can look at it and go, ah, darn it, I forgot to do that. So if coin equals 1, so we're going to say that maybe is our heads. Heads equals heads plus 1. And again, you can use the shortcut ones. This is just habit for me, so I'm going to say heads equals heads plus 1. We also are going to go back out here then, and we're going to do an else statement. And an else, since in this case we only have a head or a tail, well, we know that if it's not a head, it's going to be a tail. And so we could say tails equals tails plus 1. So my loop is now going to run, and I'm going to get this set of variables in here. I'm going to miss one thing in here. Notice counter less than target. I need to also put in something that increments that. Counter equals counter plus 1. If I don't do this, that loop is going to run forever. And I'll give you an example here in just a second. We'll show you what it looks like. So all the way down at the bottom of the program, I'm going to put my input. So this is important when I'm grading them, because if I just double click on the program, it just executes really quickly and ends, and I don't get to see the results. This just holds it open. So make sure you have that in there. And I saw a few that also did not have that. So while this print loop, so all of these things ran, so it executed that, ran it 1,000 times, we hope. And so now I need to print out some output. So I'm going to print, and I'm going to print this really easily because, well, we want to make this as easy as possible. And I'm going to print the number of heads. And then I'm going to put a space, tails. And again, we could make this much fancier. I just want to get this details out, and I want to see if we can make this program work. Now the other one I'm going to print, just so I can verify that that counter really did go up to the value I thought it did. And I don't need to necessarily run this, but it makes my life easier if I can verify what's going on. So I'm going to have, it's going to print tails, or heads and the heads, tails and the tails. Oop, I have an extra piece in there. And then counter and counter. All right, so it's going to print out 3 things after this program runs. So I'm going to do a file and save this as a piece of code. So I'm going to just store this documents, Python Spring, and I'm going to do coin flip test. All right, so when it ran, notice over here on the left-hand side, it said, oh, heads 496, tails 504, and my counter hit 1,000. Now, that's interesting, because what I thought was going to happen is my counter is going to hit 999, and then that's going to display that result. What it really did is it added one more, and then it failed out of this loop. So in other words, it ran 999, lets this section run one more time. 1,000 comes up here and goes, oh, nope, that's not true, and exits down to the next line. So interesting little piece for those of you that are looking at that. It is kind of handy because we could say, hey, you ran it 1,000 times. Here's a couple of variations and some interesting things I had people do. One of the students in here said, you know what, we're flipping these coins 1,000 times. Do I even need any of this? Oh. And so what they did, they said if coin is equal to, and they said instead of saying any of this, I know that tails is going to be equal to this. Is equal to target minus heads. Very clever. Shorten it up just a little bit. And that works in this particular example. So we only have a two-sided coin. If we had a six-sided dice or something, but again, it was a clever piece to change that just a little bit. And we could run this again then. Run. We could see if my typing really quickly. And again, 468, 532, counter equals 1,000. So clever way to do that. And in fact, you could even put it in where your tails got converted here. So we could even say, you know what, we don't even need this variable tails. And we could actually just eliminate it and just put it that way. So again, interesting ways to do that. And this is not by any means the only way to do that. There are literally 100,000 different ways we could do that. The next challenge with this program, and I like to break these down so you have one or two pieces, and then we can look at it and see how you can solve each individual piece. And so if you look at the whole program and you're going, oh my goodness, I'm overwhelmed, figure out how to solve one small piece of it. So here you made a loop that ran 1,000 times. It generated a coin. Then we had to do something with that coin. In this case, we used an if statement, and we got a counter. So in other words, that sentinel value, we know we had to increase that. So we've made it as short and sweet as we can probably do. Well, our next piece said, you know what, I'd like this program to repeat. So if the user got to the end and said, I'd like to repeat this. And so at the video last week, I said, you know, here's one way you could do that. So you could create a while loop that this section here is going to then set in. So this piece here. So let's take a look at that really quickly. So while, and I just used the variable response is equal to yes. Now we'll talk about this just a second, but first I need to indent everything in here that's going to be part of this loop. And I need to indent all of these items. So I'm going to highlight them, and I'm going to come up here to my Format tab, and I'm going to say I'm going to indent. Now, notice I indented that entire block, so this all will run when my response is equal to yes. All of this is going to loop. So I need to do something. I need to first initially set a response here that's going to let this run. So my first thought is I'm just going to put response equals yes. Now this will let it run once, and then it's going to try to get a value back out of that response. Well, to do that, I'm going to have to put an input inside of my loop. So this is my priming entry. This is my response inside of there. So response equals input. We don't need to change it to an integer or anything else. Remember, they always come in as a string. Please enter if you want to play again. So now it's going to come up here and it's going to ask, hey, do you want to play this again? So let's save my changes and let's see what happens. See if I manage to pull this off. Heads 476, tails 524, counters equal to 1,000. Perfect. Do I want to play again? So I'm going to enter a lowercase yes. Oh, wait a minute. I see a problem developing. So it is looping my program, but notice what's happening. I get the exact same number of tails and heads. So why is that? So let's go back to our program, take a look at it really quickly. So I run this program the first time, and counter spins up all the way to 1,000. But when I try to run this program the second time, notice it doesn't go back and have a chance to reset those. So I need to actually have a way to reset all those. And so I'm just going to throw them back at the bottom here. So I'll do it this way. So enter yes if you want to play again. So if we're going to stay in that loop, then I'm going to say coin equal to 0. I'm going to set my counter equal to 0. I'm going to set tails equal to 0. And I'm going to set heads equal to 0. So then each time this outside loop, so this whole piece runs, at the end of it, it's going to reset those counters so that we can run it again. So let me try it one more time. 497. So notice now it's getting different results each time. So is this the only way to have done this? No. Could I have done it 100 different ways? Could I have done it much cleaner? Yes. So some of this response, so I'd want to clean that up a little bit. So here's my other question in here, and I think this is a fair thing. You've already seen like you can do a lower, a dot lower, dot upper. So one of the things I would think about doing is taking that response, converting it. You could strip off the first letter, so we've got some slicing and dicing tools we're going to show you. But really quickly, I could even do this. Because that OR statement says, does it have to be equal to capital Y? So we could do a couple of different ways in there. So you could say OR response equal to Y, just in case they put in an uppercase. So you could clean this up, make it really pretty, do some really interesting things. But this is a shorter, hopefully, version of what some of you have created. Same structure as most of you. You count some way. Now, are there some really quick shortcuts in Python? Yes. In fact, I think when we did this before, there were some ways some students in an upper division class, when we did some experimenting, got it down to 5 or 6 lines, and we could do that. One of the things I saw was several people ended up finding a website that defined this as a function and tried to run a function. We're going to get to functions. Right now we haven't quite got there. I want you to see this logic of how you can write a program this way. The other one I saw several people tried to use in their loop, instead of just letting the loop exit out on its own, you tried to use a break or something else. And they have their purpose, but in structured code, most of the time we want to create a loop that will actually execute all the way through and not break or use an escape sequence out of it. So this is one way you can do that. So if your program doesn't look exactly like that, that's fine. Make sure it actually runs. I went into several of them, and when I tried to run them, it automatically gave me an error code. Use those tracebacks. Use that and see what happens. So if I do, let me make this a little simpler so you can see what some of those errors look like. I'm just going to get rid of that because it's one extra piece in here. So I said one of the things I tend to do is I forget to put the double piece in there. And it's going to say, oh, you've got an invalid syntax. All right, equals. Or if I do this. So I didn't create that variable ahead of time, and it's going to actually compile, but over here I get an error that says, hey, you've got an error in this program. Well, response equals, why does it say that? So line equals 12. So if I look at line 12, it's erroring in this line, but it's really caused by the fact that I don't have anything that says what response is equal to. Python tries to hold your hand. It can't make up variables for you. All right. Hopefully this will help you guys as you start working on this week, and I'm going to start recording in some content over our textbook. You have to. Did I have enough have tos in there? Go through the material in the textbook. Excuse me there. So you have to do that. All right. I hope everybody is doing well, and we will look at you in another video really quickly. Thank you.